Well, so now we're in lesson 5.4. And so we're going to start with reminding ourselves how to take the derivative of the natural log. So f prime of x, if f of x equals the natural log of x squared minus 1. So it's pretty straightforward. We know that we're going to just take the derivative of natural log as 1 over the argument, so x squared minus 1, times the derivative of the argument, which is 2x. So that leaves us with 2x over x squared minus 1. And that is our derivative. So it's very straightforward. You can simplify it if possible. This one's not going to be simplifiable, but that's our basic idea. So let's go ahead and move on. And so we're talking about the natural exponential function, which is e to the x. We spent some time with this in Math 3. We've probably put it aside a little bit. E is a very confusing number, but it is probably the coolest number. So if you recall now you should really not be taking any notes about this next stuff. We're going to go through it really fast. It's a very cool number, and we did an experiment last year with this formula, and figuring out what happened as we changed n, the number of times we compounded per year, because while compounded continuously, which is where we get e, that's where it came from, is actually an impossible thing. It's so close to regular things that we do it. So we've got our interest, blah, blah, blah. So we start with interest only once a year, then we've got 12 times, same question, we get this number. Then we've got 52 times, we get this number. Then we've got daily, or 365 times, we get this number. And then let's see, if we went hourly, that'd be this crazy equation, which is this number. Turns out this number is getting closer and closer to e. We're approaching a limit. So as many times as our calculator will let you, we're approaching the number e. So e is this number that what happens when we compound over and over and over and over, constantly, basically, constant compounding. And so that's where the number e came from. Again, it's Euler's number. So we know that the natural log is base e, and so that we know that the natural log of e to the x is x, which, because they are inverses, we know that. So we double check this, and so yes, they are inverse functions. We already knew that. So again, you weren't really supposed to be writing any of that down. That's all stuff we talked about last year. So this is also stuff we talked about last year, is how to solve that. You can take notes on this if you want, because you do need to sort of remember how to manipulate things. Take the natural log of both sides. And we know they're inverse functions, so this undoes that, and we're just left with the exponent. 2x minus 1 equals the natural log of x. And so blah, 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 we get this fancy thing. So pretty straightforward stuff. No big deal. If we wanted to solve this equation, we're going to make both sides the exponent of e. We're going to use inverses. We've got this, and so we end up with e cubed minus 5. And again, just stuff to know. Now, here's the part that we don't know how to do, is how to take the derivative of e to the x. So it's really easy and awesome, and you'll probably remember forever, because it's really, really, really cool. So we've got the natural log of, we take the derivative of both sides, because we know how to take the derivative of these. We get that. And so we take the implicit derivative, and now we have something really strange happen. So let me actually just do this with paper. So I know that the derivative of this is 1 over y times the derivative of y, which is equal to 1. And so right? And so multiplying both sides by y, we have y prime equals y, which is bizarre. How did that happen? That doesn't really, when is it ever a derivative been equal to itself? So, basically, the derivative of e to the x is e to the x. That's what that's saying, which is a little bizarre. So if we take the derivative here, this way, it's a little bit more clear. So we're going to multiply both sides to the e to the x. So the derivative of e to the x is e to the x, which is crazy. That's mind-blowing. The derivative of e to the x is the function. So e to the x is the only number that is the derivative of itself. The derivative of 1 is 0. The derivative of 0 is 0, but that's kind of pointless. So everything else is we always have these fancy rules we have to remember, but not now. The derivative of e to the x is e to the x. It's the only function that is its own derivative. It's awesome. What's the derivative? It's what we started with. So there's no memory, nothing to remember here except for that there's nothing to do. And so it's pretty awesome. Of course, we'd have to take the derivative of an argument if there is one, that kind of stuff. So let's go ahead and try this one. We're going to get f prime of x equals the derivative of 2x squared, which is 2x, plus the derivative of e to the x, which is e to the x. All done. No big deal. That simple, that straightforward, nothing going on there. And so, let's try this one. You try it. I'm going to pause. I'm going to wait 30 seconds, and then I'll give you the answer. So you don't need to pause, because I'm just going to wait 30 seconds and give you the answer. Maybe only 20 seconds, 30 seconds is an awful long time. So f prime of x is equal to e to the 5x times 5, because we still have to take the derivative of that. That's it. It's the answer. You can write 5 e to the 5x, but that's all we're doing here. So it's pretty straightforward. It's pretty simple. Nothing to it. Go ahead and try this one. Pause the video because I'm writing the answer down right now. So there you go. E to the x squared. The derivative is e to the x squared times 2x. No big deal. What about that one? What's its answer? And again, I'm going to stop writing these down. I'm just going to splash this on. Write down what you think the answer is. We'll come back. What do you think the answer to this one is? It's a little bit trickier. That 3, what does that do? Write down what you think the answer is. Again, we'll come back in just a minute. So, let me go back to these two that I said we would do later. This one is e to the negative x times negative 1. And so that's f prime. And this one is 1/3 e to the x minus e to the 2x. That's our original. And so that's just going to sit there. The derivative of the first one, the derivative of the second one. There's my answer. Clean it up a little bit if you want. No big deal. So that's f prime. So, it's really almost too easy, which is cool. It's nice when something is easy. We've had a lot that's been difficult over the last little bit. And so it's nice when something isn't difficult anymore. So let's go ahead and that's it, actually. That's it for today. The next one is our next lesson. So good luck. Try to remember that. It's shockingly as easy as it seems. Good luck to you.